We will be discussing trigonometric substitution today. And before we go to solving the integrals of a certain expression which involves trigonometric substitution, now let's discuss first the table. Okay, this will be our guide to solve uh, integrals involving expressions like this. All right, so here, okay, let me just change the color pen. Okay, red. And given an expression, the square root of a squared minus x squared, now it says here that we will be using this expression or equation x is equal to a sine theta, or keep in mind that we will be using sine theta here, okay? And for an expression which is equal to the square root of a squared plus x squared, now we will be using x is equal to a x is equal to a times tangent theta, or tangent theta. And for the expression which is the square root of x squared minus a squared, we will be using the equation x is equal to a times secant theta, or secant theta. For me, it's easier to determine or to keep in mind the function to be used, okay, with respect to the expression given. All right, so again, minus a squared minus x squared sine theta, a squared plus x squared, that's tangent theta, and x squared minus a squared is secant theta. And later you will know why. And of course, we need also to consider the restrictions for the theta here, okay, with respect to the given expression, as well as the trigonometric identities, okay, with respect to the given expressions. Okay, so now let's apply the table, I mean the given techniques or the guide given in the table in the first problem, which is the integral of 1 over x squared times the square root of 9 minus x squared with respect to x. So here, now our radical, okay, our radical expression is in the form of a squared minus x squared. So let me just change the color. Okay, again, the radical expression is in the form of 9 minus x squared, and this could be rewritten as 3 squared minus x squared. Okay, and again, let's try to, okay, let's use or draw a right triangle here, where we're going to place the values 3 and x. So in the given expression, uh, this can be associated to a right triangle expression, all right, where 3 is our hypotenuse and x is one of the sides, and the radicand, okay, or the square root of 3 squared minus x squared could be one of the other side, one of the sides of the triangle, right triangle specifically. So since we already identified the hypotenuse, we have here 3, all right, and this is our angle, theta. Okay, and as we said, since we have the square root of 9 minus x squared, we will be using sine theta, correct? So let's go back. So here, x is equal to a sine theta. But then again, just remember the function associated with the expression, which is sine theta. So if we have sine theta, all right, sine theta, if this is our theta, this would be opposite over hypotenuse. So opposite over hypotenuse, our hypotenuse is 3. Okay, and we want to make this equation to be simple. Okay, we will be avoiding complicated expressions for us to easily identify the derivative and other things that we are going to do with this equation. All right, so for us to make this simpler equation, now we can place the opposite part of theta to be x, such that we could have x here. Oh, sorry, it should be x. So let me just erase that. Okay, it should be x. Okay, so this is x. And if this is 3, this is x. Therefore, this side is equal to 9 minus x squared using the Pythagorean theorem, right? Okay, this is x squared. Okay, so if we are not going to use this function, okay, like cosine, then we will be using this side, which is the square root of 9 minus x squared, and that's a more complicated expression compared with x, right? Or if we're going to place this square root of 9 minus x squared here as the opposite side of the angle theta, then we will have sine theta is equal to the square root of 9 minus x squared over 3, which is more complicated than what we have found here, okay? So now we can solve for x, which is equal to x is 3 sine theta. Okay, it's simpler compare with or dealing with this expression, right? Okay, so we have already found the value of x in terms of sine theta. Okay, so now what's the use of this? The use of this is that we can substitute all of the x's by this expression, 3 sine theta. Okay, so we know that x squared, we're just going to square both sides. So if x is equal to 3 sine theta, okay, 3 sine theta, therefore x squared is equal to 9 sine square theta, correct? And also, how about the square root of 9 minus x squared? How are we going to express this in terms of trigonometric equation or expression? One way to do that is to substitute x here. Okay, substitute. Okay, let's do that. Let's do it. So we have, okay, 9 minus what is x squared? X squared is equal to 9 sine theta square, right? Okay, so this becomes 3 square root 1 minus sine square theta, which is equal to 3 square root of cosine square theta using the identity, all right, the Pythagorean identity. And this is 3 cosine theta, correct? And of course, cosine should be positive, all right, since we restricted our theta when we using this expression uh, from negative pi over 2. Let's move that from negative pi over 2 to pi over 2. That's why we are always sure that this is always positive. So instead of expressing this expression, okay, to be or as 3 times the absolute value of cosine theta, we can express that as 3 cosine theta as simpler expressions. And since we all knew that this will always be positive, okay, or we can, this can be also zero once theta is equal to negative pi over 2 or pi over 2. All right, so we have already expressed square root of 9 minus x squared to be equal to, so this is equal to 9 minus x squared, the square root of that equals 3 cosine theta. Okay, so we have already found the equivalent expression of, okay, of x squared and the square root of 9 minus x squared. So we can now substitute these values, these simpler values, in terms of the trigonometric functions sine and cosine, all right? However, guys, we don't need to pass through with these steps just to identify the equivalent expression of the square root of 9 minus x squared. We can also use the right triangle that we draw to identify the equivalent value or expression of this, okay? Now, how do we do that? Now, we knew that the square root of 9 minus x squared is present in, or is one of the sides of the given right triangle. So which means we can use a certain trigonometric function uh, to express it, I mean, to express this in terms of that function. So what we know is we need to use this, okay? So with respect to the given theta, the square root of 9 minus x squared is adjacent. And instead of using the opposite side, which is the x, now we can use the hypotenuse since we try to deal with constants than variables, right? So to make the expression simpler, again, try to deal with constants instead of variable. So we have adjacent, and hypotenuse. Now, what is the trigonometric expression or function that deals with adjacent hypotenuse? Okay, so we have, oops, we have a SOHCAHTOA. So ka means cosine, theta is equal to the square root, which is the adjacent part, 9 minus x squared over 3, correct? And we can rewrite this in this form. 3 cosine theta is equal to the square root of 9 minus x squared. Okay, 9 minus x squared. All right, so we have already identified the equivalent expression of the square root of 9 minus x squared, which is 3 cosine theta. Here we go. And if we're going to check, this is just equivalent to what we found here, right? And for me, this is simpler and easier to do compared with this. But you can also do this, okay? So each method or the two methods will give you the same answer, the same value, all right? So we have already found the x squared and the equivalent of x squared and the radical, I mean the square root of 9 minus x squared in terms of a trigonometric function. So that's why it's called trigonometric substitution, because we're going to substitute the trigonometric functions or expressions to the given expressions or factors in a given integral problem. Okay, so let's move on. So again, I'm going to copy the expressions that we already found on a given previous slide. So x squared is equal to 9 sine squared theta, all right? And the square root of 9 minus x squared is equal to 3 cosine theta, if I'm not mistaken. Let's double check. Yeah, that's true. Okay, so let's substitute that here. So we have, okay, the integral of x squared times this 9 minus x squared with respect to x is equal to, okay, now we forgot to get the value of the expression of dx in terms of cosine theta. And we know that x is equal to sine theta, right? Or 3 sine theta. So for us to get the equivalent expression of dx in terms of trigonometric function as well, so we need to differentiate these equations. We have dx, and the derivative of 3 sine theta is 3 cosine theta with respect to theta. So this becomes what? This is now the integral of dx, which is 3 cosine theta with respect to theta over, and our x squared is equal to 9 sine squared theta. So we're now substituting the trigonometric expressions, okay? And the square root of 9 minus x squared is equal to 3 cosine theta. So 3 cosine theta, correct? Okay, so I think we substituted everything correctly. All right, and let's simplify. So let's see if we could simplify some of the factors. So we have 3 cosine theta. We can simplify this, we can simplify this. So what we have here is, What we have here is the integral of 9 sine square theta with respect to theta. All right, so let me just put it to white. Okay, so this is now our next problem to solve. So let's copy. We have the integral of 9 sine square theta with respect to theta. Okay, so the problem is, how are we going to solve this? We can put the constant as a coefficient of the given integral. So this is 1 over sine square theta with respect to theta. Okay, and a sign off, we don't have a formula, a direct formula for the integral of 1 over sine squared theta. However, we can express it in other form. 1 over sine is equal to cosecant theta, right? So therefore, 1 over, okay, let me write that here. 1 over sine theta is equal to cosecant theta. So therefore, if it's 1 over sine squared theta, this is equal to cosecant squared theta. So therefore, this is cosecant squared theta with respect to theta. All right. Now, our main concern here is to take or to find the antiderivative of cosecant squared theta with respect to theta. But all I know, if this is y, and then this is equal to, okay, what's that? Cosecant. So that's tangent, right? Okay, tangent. Oh, sorry, it's cotangent. Okay, so let me just erase. All right, let me put a pen again. Okay, and I know that, okay, what I remember in the derivative is if it's y is equal to cotangent, okay, and its derivative is equal to cosecant, negative cosecant square, right? Of course, there must be an angle here. Okay, so this is just my scratch paper. So the derivative of cotangent theta is equal to, okay, it's equal to, it's an arrow, sorry. Okay, let me erase. It's supposed to be an arrow. 10, okay. Okay, negative cosecant squared theta. So therefore, if we're going to take the integral of this, then we will have this, right? So therefore, the integral of cosecant squared theta is equal to negative cotangent theta, right? So this becomes 1 over 9 times negative cotangent theta plus c. So this is now our okay, antiderivative of this given function or given expression, okay? However, our given value has x's and there are no trigonometric expressions or functions given. So which means that our answer should be expressed in terms of x as well. So our final answer here will be converted, should be converted in terms of x if possible. So we have, let's move on to the next. Our last step was, okay, let's move back. Negative cotangent theta. Negative cotangent theta over 9 plus c. Okay, and for us to get or express cotangent theta in terms of x, of course, we need to move or to use the right triangle again, okay? And if you remember, the right triangle was expressed in terms of the hypotenuse is 3, this is x, and this is 9 minus x squared. All right, if I'm not mistaken. So let's check that. Yeah, 3x and 9 minus x squared. So yeah, this is true. And of course, this must be right. So what is our cotangent theta here? Cotangent is cho-shakao. Cho-shakao. Okay, cho means cosecant, hypotenuse over opposite. Secant is hypotenuse over adjacent. And kao means cotangent equals adjacent over opposite. So adjacent over opposite. Adjacent of theta is 9 minus x squared over the opposite, which is x. Therefore, cotangent theta is equal to the ratio of the square root of 9 minus x squared and x. So let's substitute that here. So this becomes the square root of 9 minus x squared over 9x, right? Okay, I just simplified the expression plus c. Or the square root of 9 minus x squared over x over 9. And once you simplify that, you will get this. Okay, so our final answer for problem number 1 is this. Negative square root of 9 minus x squared over 9x plus c. So this is our final answer for this problem. Okay? And I hope you got that correctly as well.